Hey everybody, here we have the Cube Computer MidTower Deluxe running. Just upgraded the hard drives in it to the new RAID 10 setup, and you may be able to see those 4 big old fat hard drives in there. And I think it's safe to say that this machine gained a little bit of extra pounds after this hard drive upgrade, because these new Toshiba X300 hard drives, they're quite heavy and they're quite bulky. So yeah, and there's 4 of them in there. Anyways, there's one thing about the MidTower Deluxe that has hardly even changed, and that's the fact that it's mostly been emphasized on blue. Back in the day, I used to call this thing the blue light special because it lit it would always light the room up blue. You'd have the little blue lights in the front, the little bubble lights right there. Original LEDs back from 2007, and of course got the blue LED fan in the back, and I just added a blue LED fan to the side. It used to have cold cathode fluorescent lamps inside. In this video, we're going to be retrofitting this 2007 case with RGB LEDs. Yes, not just putting a strip inside the case to light up the inside with RGB, but we're also going to be retrofitting these bubble lamps on the front of the case with RGB. Alright, so the first step is we're going to need to take the bezel loose on the system. So we're going to pull the side panel off. In fact, I'm going to go ahead and disconnect this fan so I can get the side panel totally out of the way. Okay, so the front bezel on this system, it just pops out. We'll have to do a little wiring work on this thing. Oh, there's a lot actually when you think about it, because we are having to custom wire in these new RGB LEDs. So I think some builders out there who use RGB LEDs are probably used to buying the strips. The RGB strips, they have the LEDs as well as the resistors already built in. So we're going to learn a little bit about resistors and how they work in this video. And this comes loose. Alright, so I got a lot of cables zip tied up inside here, so I'm going to need to pop the zip tie here. So we are totally redoing this wiring in here. It's been a while since I've had this front bezel off this machine. There's one thing I didn't much care for about this machine, is the fact that they have the power indicator LED to set off 5 volts, when personally I think it should be fed off the motherboard. I may change that since I'm going to be in here redoing this wiring. Alright, so I'm not going to be able to get y'all the best view of everything I'm doing here, simply because, well, I'd have to take loose a whole lot of wires. For example, the wires that provide, of course, the power reset and disk activity, I had to go disconnect all of those. I probably am going to replace this right here with a traditional LED, because the thing is, I had to replace this LED a few years back because, well, the original one burnt out. And I mean, not sure if they just didn't have the, I mean, there is a resistor in here. I do see there's a resistor. Not sure what value they use because it's all heat shrink, you can't see what it is. I have to wonder if they perhaps overdrove the LED that was in here, or it was just a bad LED. But I'm going to probably end up ripping all this out, because as part of this retrofitting, I'm going to have to get rid of the 5 volt supply, because, well, the RGB LEDs are fed directly off the motherboard. So we're going to have 4 RGB LEDs. And of course, this would not be complete without a freaking dead stink bug. Who knows how long he's been in here. But, got an LED. Let me see here. So we got an LED down here, as well as there and there. So the first thing I'm going to do before I go too deep into this is we need to verify that the RGB LEDs I have here are in fact the correct size. So I should be able to just pull one of the original LEDs out. That should work just fine. The next thing we need to do is we've got to remove the old wiring. Now the switch, so the front bezel on the case has this little switch here to where you can turn on or turn off the bubble lights. First thing I need to do is go ahead and remove the original LEDs and associated wiring. It's just hot glued into place. So it appears the bubble lights are going to have to come up a little bit to get the bottom ones out, but we'll figure that out once we get there. A second dead stink bug. What is it with these dead stink bugs? Okay, so I figured out the trick with these bubble lights. So these little plastic pieces actually snap loose on the bottom here. So let me see here. This one is actually for the other side, and that one goes, actually I think I had it right the first time, but anyway, so these literally were just glued on. A little bit of glue right there at the ends there, and that's just glued on right like that. So what's nice is makes my job a little easier here. So once you get those out of the way, the little bubble lamps just come right out completely. So you can actually take them completely loose. Therefore you can do your LED wiring and all that good stuff. So there you have it. Okay, so on Amazon I purchased some RGB connectors to connect to the motherboard, and also purchased, I think it's about 10 feet or so, or 10 meters of RGB cord. That being said, first thing we need to do here with the wiring is we've got to get a rough idea how much we're going to need. So the way this case had its LEDs wired was in sort of an H pattern. So I got to get the old wire out of here first. So the way this works, this computer case had the wiring done sort of like the shape of the letter H, capital H. So we're going to go back with pretty much that. So the way this is going to work is we're going to have, of course, a feeder wire coming in from inside the system from the motherboard to the front, and that's just going to get an approximate figure on how long I'm going to need that to be. I'm going to go a little extra just to be safe. So for this we're going to need, of course, a soldering iron, solder. We're going to need heat shrink tubing. We're going to need resistors, which we'll focus on in a moment. And of course the RGB connector, as well as the RGB wiring and RGB LEDs. Okay, so since the previous wiring in this case followed the figure of a capital letter H, I think we're going to go back with that sort of pattern. That being said, we're going to get a rough idea how much wire we're going to need for these runs. So We've got our two top runs here. Now I just need to do our bottom runs, which are close to the same length, but not exactly. Yeah, close but not exactly. We'll feed a little bit through the case just to be safe. Alrighty, so in the next part we're going to be soldering up the wiring for the LEDs. Okay everybody, so I'm adding this new footage into the original 2022 video because I never did address the difference between addressable RGB LEDs and standard non-addressable RGB LEDs. So in this video footage, what I'm putting together is non-addressable RGB LEDs. Now, you may encounter some motherboards that do not have headers on them for non-addressable RGB LEDs. Now, this motherboard here, for example, has both non-addressable and addressable. So more or less, the motherboard itself has built-in transistors that control the drain current on the three separate colors in the RGB LED. So you might be able to actually see them right there. So in this case, what we're doing is we're setting up where the motherboard itself regulates the drain current. So these RGB LEDs, as you'll see me describe in a moment, they are what's called common anode, meaning 12 volts is supplied to the anode on the RGB LED, and through each of the three colors you have a current limiting resistor on the cathodes, and that in turn gets plugged into the G, R, and B, so green, red, and blue connections here. And the way that the RGB lights work is the transistors control the pulse width modulation on the drains, on the drain connections for each color, and that in turn can adjust the brightness of each color and therefore adjust the color. Now, the addressable RGB LED header relies on RGB LED strips or devices that have a built-in RGB controller. So if your motherboard only offers this header, you will need to purchase a standalone separate RGB controller where you can control non-addressable RGBs using an addressable header on the motherboard. Hopefully that makes sense. Alright, so let's take a moment to understand the pinout of the LED. So this is just a rough drawing I did. So the LEDs that we're working with are common anode LEDs. So you have a common power source, and each of your three colors, your red, your green, and your blue, are drains. So the way it works is your motherboard has a plus 12 volt power source. Okay, so this actually gets connected directly to your anode. So it's a common anode, so the anode of the red, the anode of the green, and the anode of the blue LEDs are each tied together. So an RGB LED, it has 3 LEDs inside one package. That's why we have 4 leads. So we have a common anode, and we have our minus R, our minus G, and our minus B. So if that makes sense. So also, and I should mention that there are common cathode RGB LEDs out there too, but we're working with common anode for this case, since that's what the motherboard uses. So we're working with the 12 volt RGB header. Motherboards also have what's called a 5 volt addressable RGB header, and I think those are commonly used for like your CPU cores and things like that. Now I should note that when you cut these leads off, what you're going to be doing, you're going to be cutting these leads off. It's like, okay, how do I know what side is what? Well, so there's a very small flat spot on the side of the LED package. You may be able to see a flat spot right there at the top there. So that flat spot will show you which side is which. So I'll go and add that to my little illustration here. The flat side is where the minus R is, and next to that is your A plus or plus A. So when you trim these leads down to size, you'll need to reference that flat spot, which again on some LEDs is pretty small. You may be able to see it there, very small flat spot. If I turn the LED around, you may see how it's round. It's totally round except for that flat spot right there. Okay, so I just got done cutting down the leads on the 4 RGB LEDs. And I've also trimmed the leads on the resistors that we'll be using. So you will need resistors with these RGB LEDs. And of course the RGB strips that you can buy and install in your case, they have resistors built in. So when you're doing a custom RGB setup like this, where you're installing actual LEDs into a case, you need to have resistors. These LEDs, for the red LED, they call for 2 to 2.2 volts, and for the green and the blue LEDs, they call for 3 to 3.2 volts. So what I did is I assumed these values, and what I did is I factored them to Ohm's law, since we're given a current of 20 milliamps. So you don't want to overdrive current to these LEDs. That's why we have these resistors. They limit the current that will pass to the LED. So I factored in Ohm's law to calculate the needed resistance value, and I selected a resistor that was closest to that value, one step above, so a little bit higher resistance. So for the red, we went with 510 ohms. So these are quarter watt resistors, or 510 ohm resistors, which have a color band pattern of green, brown, brown, and gold for these, I believe, are 5% tolerance resistors. So for the green and blue LEDs, I chose 470 ohms, which has a color pattern of yellow, purple, brown, gold. So I have to keep that in mind. The green, brown resistors will be used for the red LEDs, the cathodes for the red LEDs, whereas the 470 ohms will get used for the cathodes for the green and blue LEDs. So what we're going to do now is we're going to have to we're going to install the resistor first. So I got a wire pigtail here. So we got 4 of these. There will be 3 resistors on each pigtail. So the black wire is your plus 12, or your positive 12 volts, going to the common anode of the LED, and you'll have, of course, your green, your red, and your blue. But in series, you're going to have the respective resistors. So we're going to put this off to the side because we're not actually going to cut it, but we're going to cut these 3 wires here. That way we can install our resistors. Now I'm going to do this off camera because it will take a little bit of time. Okay, so I've got the 3 resistors soldered in line with these wires. Now I just need to install some heat shrink tubing over them, so I'll be using this heat shrink right here, which is just big enough to get over those resistors. Not sure what size is off the top of my head, but what I'm going to do is I'm going to cut it to size and then slip it over, and we'll be ready to attach the wires to the LED. Okay, so off camera I went ahead and finished up this wiring harness. So here we have the connection that goes to the motherboard, RGB header, and I have that heat shrinked into some wire running up to the front of the case and up inside the front bezel. And here's where all the connections meet. We have our 12 volts coming through here. This goes through this little switch that goes in the top of the front bezel to turn the lights on and off. Since it's common anode, we could do it this way. And the estimated current that we'll be pulling is about 240 milliamps, which should be fine for this little switch. Shouldn't be too much for it. That comes back and it meets up with the black, which is the anode, 12 volts. That feeds all 4 LEDs with 12 volts. And of course we have our blue, green, and red going through the respective resistors on each LED. And of course wired in an H pattern to match the wiring in the original case. So now it's really just a matter of installation. Okay, so I have completed installing the wiring back into the front bezel. I have also retrofitted the power LED to actually be fed off the motherboard instead of just 5 volts through a resistor. So that way, if the computer is ever in sleep mode, it would actually reflect as such on the power LED would flash. Not that the MidTower Deluxe ever sleeps, but hey. Got the bubble lights, or bubble strips, back in there. Got the trim back installed. Yeah, these trim pieces on the bottom are actually what hold the bubble lights in place. Little known fact about this thing I learned when I was tearing this apart. So now it's just a matter of putting it all back together. And while I'm in the process, I'm gonna probably stick in an RGB strip inside the case there. So I'm gonna put this back together. Okay, so the system is back up and running, and you notice something different? Well, years ago I used to call this thing the blue light special. Right now it's kind of like the red light special. Right now the RGB controller has not really been programmed to go through a specific pattern. It's just defaulting to red at the moment. So the inside lights as well as the front lights are all red, but give me just a moment, I'm going to go ahead and set this up to where it will cycle through a pattern. Okay everybody, so I got some RGB software installed, and I now have the RGB lights cycling through their colors, kind of like how the Black Max is set up. Not bad, not bad at all. So for all these years, MidTower Deluxe was just stuck with one color, blue. Now it can do whatever color it wishes. Any color you like. That's one of the nice things about RGB. So yeah guys, that was a process of retrofitting an existing computer case with RGB LEDs. As you've seen, it is a bit involved. If you want to do it right, it is a bit involved. It does involve some soldering and stuff like that, but overall not too difficult, but it can be time consuming depending on what you're working on. Of course, this system here, we had 4 separate LEDs in the front bezel, and I wired those up so that in the future, if I wanted to, I could actually separate the LEDs and have them on different channels. That's one of the reasons why I chose resistors on each of the LEDs. So in case you wondered, that's why. So there you have it guys, the MidTower Deluxe finally has RGB lighting. It's about freaking time, at least I'd say. About time. So anyways, that wraps up for this video. Hope y'all enjoyed it. Thanks for watching.